Welcome. My name is Kirsten Wilson.
Good morning, my name is Erica Zhang.
Hello, I'm Gretchen Jordan.
We have been studying Big Walnut Creek watershed, and our question is, how is the diversity of fish in Big Walnut Creek impacted by the quality of the habitat, dissolved oxygen, and water clarity?
So the Big Walnut Creek watershed is in central Ohio, and it covers the Franklin, Fairfield, Licking, Morrow, and Delaware counties. And as you can see with our picture here, half of the watershed is developed and the rest is used for cultivated crops. And I circled 2 large bodies of water here. And you can see that they are surrounded by a lot of green, which means that they have a very foresty or riparian zone, which is a good thing. And the Big Walnut Creek is 74 miles long.
The most commonly caught fish in the Big Walnut Creek watershed is the largemouth bass. Big Walnut Creek watershed has a land mass of 190 square miles. In addition to that, it supplies one of the largest of Columbus's reservoirs. For example, the Hoover Reservoir has 3,073 water surface acres and holds around 20 billion gallons of water.
Hypotheses! If the habitat quality increases, then the diversity of fish will increase.
Adding on to that point, if the riparian zone is filled with rooted vegetation, such as trees, bushes, and tall grasses, then erosion that leads to high turbidity can be reduced.
And then the turbidity made me think of the dissolved oxygen levels. So I hypothesized that if the riparian zone is shady, there will be higher dissolved oxygen levels because of cooler water temperatures. And I hypothesized this because cold water holds more dissolved oxygen than warm water does. And if the dissolved oxygen levels and the water clarity increase, then the fish diversity, or IBI, will also increase.
I hypothesized that as the quality of the habitat increases, the diversity of species of fish increase. As you can see on the left, it is the diversity of species of fish which go from 12 to 60. And along the right, it's the quality of the habitat which go from 0 to 100. You may be wondering what QHEI stands for. Well, it would need to have a good riparian zone with vegetation, and it helps with erosion and provides shade. A good rocky substrate along the bottom, and natural meanders, and riffles, runs, and pools. As you can see along my graph, when the QHEI increases, the IBI increases. When the QHEI decreases, the IBI decreases. This supports my hypothesis.
I was wondering, if the quality of the habitat is good, then there will be more water clarity. Seki, or Seki discs, are these small little discs that you put in the water. The deeper you can see them, then that means the water is clearer. And if the water is very clear, then more fish species would be more successful in that water. This is because they can see their food, and the sediment won't clog their gills, so they can thrive in that water. In addition, the sediment won't sink and kill their eggs, and their species can survive. My data is mostly consistent. That the circled area is an example of my data supporting my hypothesis.
So then if the dissolved oxygen levels increase, the fish diversity will increase. And here's my graph. On the left, I have the diversity of fish, or the IBI score. And on the right, I have the dissolved oxygen levels. So you can see this middle circle. It shows that When the dissolved oxygen levels decrease, the IBI also decreases. And this circle on the right shows that when the dissolved oxygen levels increase, the diversity of fish also increase. So my chart supports my hypothesis. And this is important because fish need oxygen to breathe just like humans do, and increased dissolved oxygen levels lead to greater diversity in the fish species, which is good.
Conclusion. All hypotheses were supported by our data.
The diversity of fish, or the IBI, will increase when the quality of the habitat, or the QAGI, is at a tolerable state for all creatures.
We also concluded that when the riparian zone has a lot of vegetation, the sediment from runoff can be reduced.
And the less sediment that enters the stream, the less turbid the water is.
Finally, as dissolved oxygen levels increase, the fish diversity also increases.
Our solutions.
Our first solution is keeping the agriculture out of the riparian zone. Try to leave 15 meters or more between the stream and your crops. The best riparian zones are filled with vegetation with roots that reduce erosion.
We also want our riparian zone to have trees because they provide shade for the stream and lower the water temperature. And as I said earlier, this allows for more dissolved oxygen.
And lastly, maintain the natural meanders in the river. This slows the water current and allows the silt and sediment to settle, reducing turbidity. Thank you.